morning, everyone, and thank you for joining us on the final day of ProQuality conference. My name is Vyacheslav, and I will be the host of today's session. Please say hi to our technical moderator, Alexei, who will be responsible for providing all the technical support during the talk. And we are starting this day with the topic commits notations for quality and testability. And I'm delighted to introduce our today's speakers, Ilyas. Hi, Ilyas.
Hi, very nice to be with you.
Ilyas, you have had a diversity journey in the IT field. You have worked as developers, I know, project manager, tech sales manager, and now you are back in development. Could you share some thoughts why it's so important for developers not just to write the code, but actually to test it properly?
So over my journey in IT, what I understood is that it doesn't really matter how to implement the thing, but the most important thing is how do we test the thing? How do we ensure that when the client gets our final product, how he's going to say that he's happy? So for me, the center point of software development is actually testing. It's not the implementation.
That's very interesting point. Thank you. Before we start the main part, feel free to ask any questions in our chats, and we will address them to our speakers in the Q&A session at the end. And we also encourage all of you to subscribe our YouTube channel. That's very important for us and for our further growth. So let's get started. And Ilyas, the stage is yours.
Yeah, thanks. So let me just quickly present myself. I worked in various fields. My first work was in embedded programming in the field of telecom and SIM cards. And today I'm in web development. I also worked in many countries like France, South Korea, and now I'm working in Kyrgyzstan. Today I position myself as a test-driven development software engineer. And as I said before, the first question for me is to know how do I test the thing and not how do I implement or write the thing. Very important thing is that I have never been a QA engineer, but I always cared about the quality of my deliveries. Today, I will first start with the context and the reason why I began to use the commit notations. Then I will present to you the commit notations that we use to ensure quality and mitigate the risks. Then I will share an overview on how this looks in real branches. And of course, we'll talk about the pros and cons and also about the use of this thing in CI/CD. And later we'll be open for questions. I really expect that you challenge the ideas that I will present, and I would really like to hear feedback from professional QA people. Now, this concept has been developed in a project called Obsidian Tasks, where I help a wonderful developer whose name is Claire McRae, who I thank for this journey together. We started pair programming in December 2022, and we have been going on so far. Some people may know what Obsidian is. It's an Electron-based browser that renders local Markdown files. This browser supports JavaScript or TypeScript plugins, and Obsidian Tasks is a TypeScript plugin that helps manage tasks written in Markdown. We have a little engine to query the tasks in your Markdown files and render them, and a little model written in Svelte. It's a front-end framework. Up to this day, I checked just this morning, we had over 2.4 million downloads. We didn't start this project from the start, but Claire picked it up somewhere in 2022, I believe, and later I joined in. Today, we are the two main developers of this project. We develop using test-driven development. Even the UI part, we found ways to develop the UI with tests, I noted in web development generally that tests is not a very well-known practice. People say like, well, we don't know how to test it, so we just write code. And we can't really agree with this position, so we developed ways to test this. We are open source, and we have a near ideal environment because we don't have any customer pressure. We choose our commitments. We love the product. We use the product. We deeply care about it, probably, because we are both users. And the very important thing, we don't have a dedicated QA team or person. We have very limited time because we do this in our free time. I personally spend around 2 to 4 hours per week on this project. Claire spends much more time than I do. Yet the time is very limited. So because of this, we need some way to release our software as fast as possible, but obviously without introducing bugs. So it happened a couple of times that we make a release, and minutes after, there is a storm of issues appearing on GitHub. And this is a really bad experience. I think that probably many developers experience this and no one likes it. So we developed our kind of way to track the risks in a release and decide how to mitigate this risk. So basically, we had to step in a QA role by ourselves. I've been using this approach myself in other projects too, and a couple of people have seen this. And when they see the Git log, because, well, the commit notations are obviously seen in the Git log, they asked me about this pattern. So I thought it would be a good idea to present this to a wider audience. Now, I wish to share this experience with you. I hope you find it useful. I'm not saying that you should do exactly the same in your projects, but I hope it will take you to some kind of new practice. Maybe you'll modify my experience. Don't take this as something that you should do. Just be inspired by it. Maybe you'll find something good for you. I mean, I hope so. Now, I believe that our jobs as engineers is to use most of our brain to be clever and smart. And my personal feeling when I perform manual testing is that I'm not being smart. I have to perform a set of manual actions that I need to follow to the letter. It's very hard to keep my attention, and there is no track unless, obviously, I record the screen and then I have to rewatch the recording. I mean, it's just madness, right? And I feel bad about this. Probably this is because I'm not a professional tester or a QA engineer. So in the context of our project with Claire, this is the kind of testing we still need to do because we need to be sure about the release. So what we try to do is to reduce the number of times when the manual testing is needed and to reduce the scope of manual testing. There is a wonderful talk by Paul Rolkins on TED, which says, the purpose of thinking is to stop thinking. And in the same way, I believe the purpose of working is to kind of work less, to make wise decisions about when to take action or not. So let me talk about the conventional commits first. Now, this is a very known specification. And when we started developing in late 2022, with Claire on this project, we used conventional commits. And also at this time, we were introduced another notation that I will show on the next slide. And the beauty of the conventional commits is its verbosity. So you put the type of the change that you made in a commit and, well, the description, the message. These are the only two mandatory fields in this commit notation. So for instance, if you write refactor column rename variables, it's very understandable. Well, you have performed some refactoring, and inside this refactoring, you renamed variables. Personally, I find this very useful because you make small commits and blah, blah, blah. I will not now say all the good things about conventional commits because this is out of the scope of my presentation. Now, one thing that conventional commits lack is the risk. So you renamed these variables. How did you perform this? Was it an automatic rename? What kind of automatic rename was it? Or did you do it by hand? Did the linter tell you that, or the compiler tell you that the names align? And obviously, renaming just one variable that is declared and then used one next to each other is a very low risk operation. But what if you rename as some global variable? So there is more risk into that. And this risk is not present in this notation. But as it turns out, there is a notation that took care of this. And this is a notation by Arlo Belshi. It's called Arlo's commit notation, and it has the risk. So it has three fields now. We have the risk first, then we have the type, and then we have the message. So for instance, if I take the same thing as refactor rename variables, the same commit message in conventional commits, and I rephrase it into Arlo's commit notation, I will have some kind of symbol to show the risk, and then the R stands for refactor, and then there is the rename variable as the commit message. Now, what I dislike about this notation is that it's not so verbose. So if you're not familiar with this kind of commit notations and you read the conventional commits and you read refactor rename variable, well, you know what it did. But here you need to know a bit more about the commit notation. You need to know that R stands for refactoring and not something else. And there are other letters that I have shown a bit higher, and it's not so obvious, let's say. The way to show the risk is also very nice. I really like it. So the smaller the symbol, the lesser the risk. The bigger the symbol, the bigger the risk. So the dot is, well, we could argue is the smallest symbol you could type in terms of space on the keyboard, so it's the lowest risk. And then comes the hat or the dash, and then the exclamation sign and the @ sign. So the @ sign being having the most space in terms of lines means that that's the biggest risk. So we kind of merged the two commit notations to take the best of the both worlds, and this is what we came up with. So we have put the risk between the type and the description of the conventional commit parts, right? So we have, let's say, refactor, then the dot rename variable. So the dot means that there is the lowest risk. What we consider the lowest risk is an automated ID action. So there are some IDs like IntelliJ IDs. They have automated refactorings. So we believe that if you do those, you are sure that you introduce no risk in your commit. There is also an extension called Abracadabra Refactor This for VS Code. It also has automated refactorings, and this is the kind of thing that we believe is riskless, is the lowest risk. Now, the next level of risk is the dash, and this is a unit-tested commit. So it means that you wrote some code, and this code is unit-tested. So for instance, if you change something in this code, if it was, I don't know, if the condition is more than and you changed it to less than, then there is a unit test failing. Or if you modify the test, then because of this change in the code, something would go wrong in this test. So there is a strong connection with the unit test. So this commit is unit tested. It's more risky because if you happen to delete the test, which it's not very good, but there is such a risk, right? Or there is the risk that your unit test is not testing the full logic of what you have written. So there is more risk in there. But that's not the riskiest thing. So the next level of the risk is the exclamation sign. And here we say, well, we don't have a unit test for this. This stuff can happen for other ways of testing. So for instance, if what you have written can be tested only with an integration test. So this is a kind of a more expensive thing to test. Why? Because you need to deploy this even in some development environment, but you need to make some kind of manual test or an expensive test. Another example of this could be access to a database, or if you are into front-end development, it could be some hook in React, a use effect hook in React. So you need to really render your application and validate by hand that, well, you did your change right, that the behavior of the system is as you expect it to be. And obviously, manual test is much riskier than a unit test, because a unit test, if you are not sure, well, you just push the button as many times as if you want, and you just run the thing again, and you are sure. With manual test, you need to have a kind of a test plan. You need to be sure that you executed the test plan. And what we do with Claire is that we do this together, which means we spend double the time because it's two people doing the same thing, but at least we are sure. But even this is not the highest risk, because it can happen that a commit is not testable at all. And this is very rare, but it may happen. This is the @ risk. When we say, well, we don't see any impact, it should work, it has to work, but we don't know. We don't see the impact of this code change. So we believe it's right, but we cannot test this. And another thing that might happen very rarely is that a commit breaks the tests. And this is what we put, where we put not one sign, but we put two signs, we put two asterisks saying that we broke the tests. This is only for development purposes, because we believe that every commit should be releasable, which means in every commit, your CI/CD pipeline should pass. And this is the kind of a commit where the CI/CD pipeline will not pass because one of the tests will fail. And we also left a backdoor where we say we don't put any risk notation, because, for instance, when you commit documentation or JS docs, or you modify a comment, well, you don't have a risk of breaking the code. You're not modifying the code itself, you're modifying something else. So why care? So this is a short presentation of what we have introduced here. We didn't want to call this, to make this a separate commit notation, because, well, we just got inspired by the two existing ones and slightly modified one of them. So Let's check a bit the numbers for the commits I have done in more than 2.5 years in this project. So here I filtered commits that I did. It doesn't matter that I did them alone. We did them together with Claire because we pair program. And I believe in kind of numbers and analysis of seeing what you have done. So you can see that the distribution of automated and unit tested commits represents, well, almost 90% of our job, of our, let's say, result, right? And we are doing slightly more unit testable commits. But the importance for me grows with the risk. So you may see that the commits that need manual tests are only 10%. So if you believe in an equal distribution between the branches, which I will talk about in the next slide, this means basically that you need to test manually, to validate manually, only 10% of the branches or the PRs that you introduce. You could say that maybe. And then the breaking unit tests commits and manual tests commits. Oh, and sorry, and the cannot be tested commits are less than 1%. I have one of each in 2.5 years, which probably means I'm not writing as much documentation as I should. So let's see how this whole thing looks in the Git log. We try to keep our branches short and use the commit notations also for the branches, which means each branch starts with a feat for feature, refactor for refactoring, blah, blah, blah. But this is a theme for another talk. So a branch can commit various commit types. On the left, you can see a refactoring branch that has only automated or unit tested commits, which means, well, we are pretty sure that we covered all our code by tests. There is no code where we introduced such a big risk that we need to mitigate it by validating it with a manual test. So we actually don't need the manual tests here. If it was a feature branch, then you would need some exploratory testing on that feature and nothing else. I mean, this is the logic that we have put behind it, right? On the contrary, on the right-hand side, there is a pure refactoring branch where you could see in the middle some commits that have an exclamation mark, which means that while doing this commit, we made a manual test. We had to validate that this commit didn't break anything. What we do in practice, by the way, is that we make that commit and we test that everything works fine. If it wasn't, we revert. So obviously, the branch on the right-hand side now will need manual validation. Now, the good news here is that you can check which code exactly needs to be validated manually. And what we do is that we watch on this, we see this code, and we test the functionality that uses this code, because there is no point in testing features that we didn't change, right? We know that their state is still the same, which is probably tested. So this is how we use this commit notation to mitigate the risk. If we have branches that have only automated or only unit tested commits, we don't do any manual testing. This is basically our quality gate in our CI/CD. We say, well, we just release. However, if there is at least one risky commit, then we do some manual validation. We have a little test plan for things that we change often, that are risky like this, that need manual validation, so that we are sure that if we do this, well, we kind of cover our bases. Obviously, you could even automate this to make this quality gate automatic in the CI/CD process, but in our project, we don't have a big number of PRs. As I said, we don't spend much time on this. Time is our biggest constraint. So we didn't automate this and make it, an official process or something. Which brings me to the pros and cons of this approach. So the good thing is now, thanks to the notation system, we have a way to decide how safe is merging a branch and releasing it. Releasing the product. If we only see commits we are sure about, well, then let's skip the manual testing, which was the automation, and so be it. Or do you need to manually test something? What do you test? This is basically our QA process. Another benefit is that this approach forces us to separate the branches and the PRs by risk. For instance, we could group the risky things in one PR and group the things we are sure of in other PRs, and even plan the releases according to this. So we separate the risks. On the other hand, this can lead to bigger number of commits and bigger number of PRs, which, depending on your company culture, well, may make you very unpopular. Another thing that you need to know with this kind of approach is that, well, you need discipline. And it's easy to do when there is just two of us and we work by pairing. So we know what we do. We kind of oversee each other. And sometimes we have debates whether are we safe? Are we not safe? What should we test? What should we not test? So it's easy to maintain this discipline when it's just several hours per week and when it's just 2 people. But if you have a team of 50 people working on a big project with a very high pace, with a very demanding customer, and you have, a big turnover of people in this team, so you need to onboard the people and bring them into this discipline, well, you have a risk that they don't understand how to use this, and then the automated quality gate, it will fail, basically. So, yeah. I would really like to hear your thoughts on this kind of things. Thank you so much for listening. I hope that this idea sparked some thoughts or questions. I'll be happy to hear your perspective, suggestions on this approach. Thank you very much for listening. I'll also be very happy to connect and discuss this later if you'd like to, and share more. Vyacheslav.
Thank you, Ilyas, for the very interesting insights regarding the approach, how developers can mitigate risks during their work. and that's a good sign, yeah, to improve quality of the product being developed. And we are moving to the Q&A part. And if you haven't sent any questions yet, that's a sign to do it right now. We can address them to Ilyas. And also, you can see on the screen QR code. So feel free to scan it. So and rate our event. And if you enjoyed our talk, feel free to assign a badge to our speaker. So let's see what questions we have right now. The first question is, so none means that nothing has changed or nothing is at risk?
Well, if nothing has changed, then there is no commit, right? None means that we just skip the risk part and we keep the regular conventional commits. So we put refactoring, rename variables. But nothing is at risk. I mean, in this case, we say that nothing is at risk. We usually use this for like installing NPM packages or modifying documentation or modifying, I don't know, comments in the code. So you don't actually modify the behavior, you modify the things around. Yeah, stuff like that. So we consider this as no risk. Thank you for the question.
Okay, thank you. Let's move to the next question we have. The next question is from Xenia. Do you see any ways to integrate AI in this approach, for instance, to understand if manual testing is really needed here or not, and so on?
Well, yeah, my feeling with AI, and this is a very strong debate, is that it's not very good with formal logic. Like we all know probably the strawberry test, right? So I would first integrate an automated CI/CD process here that has very strong formal constraints. Like, well, if you have a risky commits in your branch, then please call the QA team to validate your thing. Oh, but there is a way to use AI here, and I believe that it's to predict which kind of functionalities should be validated in the product by this code change. Yeah.
Okay, cool. Thank you. Next question is, please, could you share the importance of keeping notations and comments in imperative case in English? Revert, comment, add, comment, develop, comment, test, comment.
Oh, this is a hard one. I don't know, actually. I think this depends a lot on the style and the convention that you have in your team. And it's not... I don't like having a religious debates in this kind of thing. It's more like, for me, all the style things come either from we have been doing like that for a long time, and this is why we do this. This is probably what I see the most. And the other way to do this is we do it this way because it helps us improve the quality of our releases, because it helps us understand better, because something. So if you're used to some style, or you integrate a team that is used to some different style, well, I don't know, I would say just bear with it, or find a team where it's different. I don't think this is so important, honestly. Yeah, I think the most important thing is to get things done and to make this help you get your things done. So
yeah, agree. Thank you. The next question is, what kind of project could potentially reuse this approach from your perspective?
Well, I think so as I said, this approach requires discipline. And my feeling is that discipline is a trait of more experienced developers. So I would say that it's not about projects, it's about teams. So probably if you have a team where you have some senior people or people who are senior, even not in terms of technology, but senior in terms of their approach to development, their approach to life. I don't know. Then yeah, this is where you would want to use it, and also probably start small. Don't roll out this on a team of 100 people. Yeah.
Thank you. Thank you for covering this question. And looks like we don't have any questions yet. Let me check.
If I may add on the last question,
Yep.
I would. The beauty of this approach for me is that you could actually do it even if you're alone on your team. If you use conventional commits in your team, well, nothing really goes against saying, well, I will add in my messages, in my commit messages, the risk factor just for me to know. And when I merge this thing, I will tell to my QA guy, hey, by the way, could you be extra cautious on this?
Mm-hmm.
This is where I fear. Could you please just
Test it
or
properly. Yeah. Just this piece of code and or piece of functionality rather than.
please help me with this. Or
Yeah.
you could say, hey, on this release, honestly, like, don't spend your time. Like, just do the basic stuff and yeah.
Okay. Cool. Thank you. Thank you for additional comments. And um, we haven't got any questions. So, Ilyas, thank you one more time for the fascinating talk and joining our ProQuality conference. Dear listeners, thank you for supporting this event. Presentation deck will be uploaded, um, in few hours, and video recording will be available within 1 month after the conference. And I would like to invite you all to our next talk in 20 minutes, where we will explore how AI can be applied for various purposes by QA engineers. So stay tuned, subscribe to our ProQuality YouTube channel, and follow us and in our social networks. So see you in few minutes. Thank you, Ilyas, and have a good rest of the day.
Thank
Bye.
you. Bye.